Hey everyone, welcome back to the channel. Today, we're going to dive deep into the world of electric motors and explore a common misconception about how they draw current. Let's start with the motor running freely, under no load. As you can see, the voltage across the motor is around 1.6 volts, and the current draw is approximately 0.2 A. This means the motor is drawing very little power. Now, let's increase the load on the motor by either braking it or applying a force against its rotation. Notice what happens to the voltage and current. The voltage drops to around 1.4 volts. And the current increases to about 0.4 A. As we continue to increase the load, the voltage drops further to 1.2 volts, and the current reaches 0.5 A. What we're seeing here is a fundamental principle of electric motors. As the load on the motor increases, the current draw also increases. This is because the motor needs more power to overcome the increased resistance. If we were to continue increasing the load, eventually the current would reach a critical point where the motor would stall or even burn out. Understanding this relationship is crucial for designing and operating electric motor systems. If you overload a motor, you risk damaging it. That's why it's important to select motors with appropriate power ratings for your application and to implement current limiting measures to protect them. In this experiment, I used a 5V motor connected to an PWM module and 12-volt power supply. In this experiment I used PWM. Let's quickly recap what PWM is. PWM is a technique used to control the speed of a motor by effectively turning the power on and off very rapidly. When the duty cycle is low, the motor receives less power and runs slower. As we increase the duty cycle, the motor speeds up. In conclusion, we've demonstrated that the current drawn by an electric motor is directly related to the load it's subjected to. By understanding this relationship, we can make informed decisions about motor selection and control. Thanks for watching.